Hey guys, it's Crimson here with another tutorial. Someone requested more not in-depth discussion on DMA, which for those of you who didn't understand from my last video on it or just didn't even watch it, pretty much what it is when you go to an address and it holds a value for your code, and you go back to that address after like a new stage, let's say, and it's not there anymore. So that is an issue for coders who, I don't know, find an address that they find severely interesting. Severely interesting, I've never heard that before. Really interesting, and they want to make a code out of it, but it keeps changing. It's a real pain in the butt sometimes, but there are easy ways to get around that, and since the Wii is pretty cool, it's even easier on the Wii than most systems. So let me show you the code that I'm working on first, or that I already made, but we'll use it as an example. Example. Wow, I can't talk today. Whenever I jump, the float value goes up. 3EA, you know, and then I jump and it doesn't show it. And I double jump and it's 3EC. Sorry about it really not updating very often. It's what happens when I record. But, so this is the code. We're gonna GCT it just to make sure it has the stuff that I want it to have, like the outcome. That was from my last video because I already made one today, but my microphone was set to the wrong microphone, and so it didn't record, and I was like, ugh, well, guess I have to make another one. So when I jump, I don't double jump, I just single jump multiple times. It's quite an interesting code, actually. But yeah, that's what it does. So, to make sure that there's no DMA on it, which we all know there's going to be, but we'll just act like we don't know, we are going to go to a new level. So click World Select, go to Wally. I always play Wally for some reason. Pirates of the Caribbean costume, and it's loading. So there are two ways in this video that I'm going to show you how you can get around this. One of the ways is breakpointing on that address and reading the assembly, which will tell you quite a bit. And the assembly usually doesn't move in games, but if it does, you can just F6 it. And then my other way is F6 too. So let's go back to this address, memory viewer, auto update, and whenever I jump it does not update, and as you could see, some of the values around it changed. So we gotta refind it. Ignore this next part because I'm kind of a cheater. But what I'm doing is I'm retracing the assembly of the game to find the address that it's writing to. That way I don't have to search for it on my really slow computer. Normally my computer isn't this slow, but when I record it's like a dinosaur. Okay, and this is the address. Go to memory viewer again. Paste our new address. And then jump, and as you can see it's this code again. So we could reapply it just to make sure it had the same effect, but I already know that it's going to, so that's cool. So we're gonna right click on it, go to breakpoint, wait for breakpoint to load, and then we're gonna do right breakpoint on it because we want to see what is writing to it, and we jump and it breaks. And as you can see, this quick little ASM lesson for you guys, this value right here is what executes what we did a breakpoint on, even though it says that it's the next address. Uh, it's just this one, trust me. Usually it is. Sometimes it's before it if you're looking for something specific. So as you can see, it says store from float register 0, which is right here, to register 3, which is right here, and it contains our target address, plus 604 addresses over. So that's that. We're going to go to disassembler now, and we are going to copy this. That way we can put it back after we're done testing. We're going to pause the game. We're going to put a NOP in there, which for you really slow people stands for no operation, which means the game just doesn't read that part of the game. And when we jump, we single jump instead of double jump. Wow, the way I describe it probably makes it sound really lame, but actually it's pretty freaking cool. So we're going to pause, paste. That's one way you can do it. Just right click, go to GCT codes. Make sure you put your original value though. And if you're fancy, you can like walk the stack and find the function for it and do stuff like that. And this is my assembly I'm working on for Black Ops to make it so people can't hop onto your account because people are douchebags. So this is the other way you can defeat DMA. You can F6 the address, the value. So I feel bad because my computer's really slow, but it's pretty old and I've been working on cleaning it up, but it's really slow when I record. Dang it. Anyways, let's see here. What's register 3? This is how you like trace back ASM, just in case you were wondering. We go to register 3, which is 80DA72BO, and we add 25C because that's what 604 is in hex. We copy, we go to memory viewer, and we paste. This is just simple F6ing. If you watched my earlier video tutorial on it, then you will already understand this part. But if you're like me and want to know as much as you can about it, keep watching, I guess. So we're going to do our basic F6 outline, which is F6 0 0 0 0 0 1. We're going to put the range. Normally I would put something more detailed, but since this is for you guys, I'll just put 8000 through 817F, and what this does is it sets the search range. I won't explain too badly about what it does or how you set it up because you should have watched my other video. So we turn on auto update, we jump and we look for values that do not change. These 3 values here seem to not change at all, so we're going to set those as the search conditions. So 80EA3F10, 80EA9310. Then we're going to set our little 14 code type to write to it, and we're going to write C at the end because it's pointer offset plus X amount of bytes. We have 3 addresses, 4 bytes each address. The first is assumed. That's why it's not 10. And 8000. 8000, if you F6, please remember to put a termination line, especially on these codes, because it changes the pointer offset to whatever it was set to. So we're going to apply this code, and we're going to jump, and sweet, we single jump instead of double jump. Double jump, not dumble jump. So, to make sure that the code is officially un-DMA'd, we're going to go to a different level as it loads. And it's loading, and it's loading, and it's loading, and we're going to check the game status real quick just to make sure it isn't frozen. Status. Oh, game is in breakpoint hit mode, meaning yes, it is frozen. No means yes. Yes, it means that it is frozen up on us. So instead of unfreezing it, I'm just going to leave it at that, because I do know that if you F6 in this game, you will freeze, because what happens is with the DMA, there is no, well, there is a pointer probably, but there is no stable values that you can search for that will always be there in the exact same bytes away from the original code. Or at least that I have found, but I'm lazy and I don't go through and test every single value, you know. So, yes, you will freeze if you F6. That is why I started off with assembly, and assembly really is important, and you really can do cool things with it if you know how to do that. People with geckos who don't know how to do assembly are truly missing out. So yeah, you can also use pointers to do this, but pointers were personally really hard for me to figure out, so I'm not going to explain that. Maybe I said this, maybe I didn't, maybe I said it in my last video that didn't even turn out, but I'm going to wait a few videos and then possibly explain pointers then, because if you follow all my videos, you'll have more experience than if you just started out that way. So yeah, comment, rate, subscribe, whatever, do it, don't do it, I don't really care. I don't check my YouTube often. If by any chance you have any questions, probably hit me up on my website. I check that frequently, like 5 times every minute. Or I guess you can send me a message on YouTube or just comment, but I probably won't see that as fast. I've been busy with school, but yeah, that's that. If you have any questions, suggestions, requests, hit me up. Yeah, there you go. Thanks for watching. See ya.